Alright, so here is the last array question on HackerRank for the interview preparation kit. And this is actually a hard question, so that's new. Haven't done one of those before. Only a success rate of 56. Perform M operations on an array and print the maximum values. Interesting. Print the maximum of the values. Okay, I don't know. Let's see what happens. Starting with a one-indexed array of zeros. I hate it when they start with one indexed. Array of zeros and a list of operations. For each operation, add a value to each the array element between the two given indices inclusive. Once all operations have been performed, return the maximum value in the array. Okay, I'm going to have to read that again because I didn't completely understand it. So the one index array of zeros and a list of operations for each operation, add a value to each the array element between two given indices, inclusive. So all operations have been performed, return the maximum value in the array. Okay. Add the values of queries are interpreted as follows. Add the values of k between the indices a and b inclusive. The largest value is 10 after all operations are performed. What? Index 1, 2, 3. Add the values k between the indices a and b. Okay, I see. So you have an indexed array of zeros. How do I know how big are the zeros? One indexed array of zeros and a list of operations. Yeah, how big are the zeros? I guess what's the max of b is probably the better question. Between 1 and n. Okay. First line contains two space-separated integers n and m, the size of the array, and the number of operations. So I'm guessing it's just a square. So it'd be a 5 by 5 array of zeros. Is pretty much what it's saying. Okay. All right. Queries are interpreted as follows. So for this one, if n is 10, so between 1 and 5 add 3, between 4 and 8 add 7, between 6 and 9 add 1. That's pretty much what it's saying. Okay. The largest value is 10 after all operations have been performed, so between between 1 and 5 add 3. Okay. Between 4 and 8 add 7. Okay. Between 6 and 9 add 1. And then the max is 10. So what if you found all of the intersections between, so all of the similarities or all of the combinations of similarities between the indices that have additions in them, and then sum up all of the k's between those intersections. And then you could search for, if there are no intersections, then you would just find the largest value of k. But you would also have to keep track of, because there could be multiple different intersections. Let's say there was a 1 and 5, a 1 and 2, and then a 4 and 5. So you would have two different intersections would be 1 and 2 and 4 and 5. So I guess that could be something. K is between 0 and a big number, so it's possible that a K could not actually add anything. So I guess an intersection, I could define an intersection as just anything that has an operation on it. And then you would find the combination with the largest K. All right. Sample input. Okay. So 1 and 2, 2 and 5. Wait. Yeah, okay. 2 and 5. Then 3 and 4. So you'd have one intersection would be 2. One intersection would be 3 and 4. And so on. I mean, one easy way to do it would just be to actually follow the instructions and then just call a max function on it. There's no way this is a hard question and it would be that easy though. At least that's what I feel like. I'm guessing that some of this is going to come what's going to come into play is how large some of these operations are, and just to I think timing will probably become an issue in some of these. So I'm trying to think of a cleaner way to potentially do this, and I think what I had before, just finding the intersections before actually adding everything, and then finding the intersection with the biggest number. So instead of going through the array, let's say, so for this instance there were 3 instructions. Instead of going through the array 3 times, we could go through the array I guess 0 times. It would only be the amount of instructions that we had. We go through those, determine which one has the most hits, and then only calculate that one. But it's possible that something with the most intersections, a given index with the most intersections, would not necessarily have the highest output because K is variant. So let's say something has 50 intersections, but I guess this would be an edge case. Let's say there are 3 instructions. We'll use these. So 2 has an intersection, 3 and 4 have an intersection, and then there's 5. Let's make this one 4 and 5. Or yeah. B has to be less than A, so maybe that's not necessarily true. Maybe the most intersections wins. No. 1 and 2, 2 and 5, 3 and 4, 4 and 5. That would make 4 the number with the most amount of intersections. But let's say 3 and 4 and 4 and 5 are 10s. This is 10 and this is 1000. Or we could leave it as 100. The number 2 would actually have the highest K. Right? Yeah. 2 would have the highest K. So do A's always increase? Hmm. Hmm. How many how many n is the amount of instructions? No, m is the number of operations. Yeah, that can get huge. That could be a lot of instructions, a lot of operations. So this is definitely like a timing based thing. That's where the challenge comes in, I think. Because you could very easily brute force it and just calculate everything up and then call a max on it, but I don't think that's going to scale very well once you get to that many operations. You're talking 2 times 10 to the fifth. So what's that? 100,000, 200,000 operations potentially. That's a lot of operations that you would have to go through um, for each. So let's say 200,000, and then you have is this like 100 million? Is that right? No, that's not right. Yeah, in the millions like of n. So you're doing hundreds of thousands and then millions times millions of operations. So that start to get pretty big. Um, hmm. Yeah, I think you're gonna have to find the intersection. I wonder if you could prove that the most intersections equals the highest points. No, because I already disproved that. If you had 3 and 4 and 4 and 5 and k was one here, and one there, then 101 would be the highest, and it's on 2, which is less intersections than 4 does. So you wouldn't be able to do that. It'd be a good start, but you couldn't do that. Yeah, just doing these overall over the entirety of an array when we get into these big numbers is just not efficient. Um, yeah, you could definitely do it, but what if you sorted the k's, sorted by k, and then from the top one down figured out where the intersections were? Mm, I don't know if that would work either. Wondering if you could put this into like some sort of, trying to think of like graphs or some sort of sorting, some sort of filtering. Yeah. I mean, either way, you're going to have to go through n to m times. You're going to have to know how many operations, or by the amount of operations, you're going to have to know how to figure out what the different weights are. So that's going to have to happen no matter what. And then if you did that, let's see. If you went through each operation and then actually added in each element or each index in each array or in the array, you would have n times m complexity if you did all of the operations if you look through all of the operations, so A has to be bigger than B, so we know it's going to cover at least two indices up to all of them. And I mean, you could filter out all the K's, all the K equals zeros. You could filter those out because those are pretty much useless to us in finding a max. I'm going to start writing some of this down. Filter out K equals 0. So there's one iteration of M. While you're going through those M's, let's see. You couldn't not find addition on every single one of them. You would have to. I'm just trying to think if there's a way to figure out which index would have the highest weight due to K at the very end. There's also the edge case that you have all of these. You could max out everything, but if K equals 0 for all of them, then the max number would be 0. You'd have to find that. There's that. I don't know. I'll just go ahead and start the brute force method and see if there's anything that happens in the middle of it. Yeah, complete the array, n and then queries. So what's n is the array, right? And then query, and then I guess this range m. Queries dot append. So the array is n, and then you have the queries is a list. Okay. For query and queries, you'd have to get the beginning and the ending index of the query. So I'm guessing they split. Yeah, they split. So let's do a split. For ABK. ABK is equal to query dot split. A is equal to ABK 0. 1, and then we have 2. The reason I'm doing this is just to stay consistent with how they split all this out down here. Then we'll need to for index in range A, B plus 1, because we want it to be inclusive. What am I doing there? We want to add K to all of these indices, and index plus equals K. And then at the very end, we want to find max value is equal to max of n. Return max value. Probably pretty inefficient. Oh, it's already in a list. Aha. Oh, yeah, append. Oh, list. Aha, okay, okay. So, I just need the query part here. This is min index, max index, and operation. Just make this a little bit more readable. Int is not subscriptable. N. Oh, I thought N was it not? It just gives us the number? Okay. Array is going to be array. Not exactly sure if that works in Python. Okay. Well, that'll do it, I guess. Oops. That's interesting. I haven't seen that before. But that's pretty cool. So is the, I imagine this is pretty much the same thing, but I like this one. 0 times n. There's our array. And then instead of n, we will need that to be array. There we go. List out of n. Okay. Now see, all of this, it worked, but I'm gonna guess that I could get this to work pretty easily. What's the input? What is it? I bet I could get this to work pretty easily. The problem is going to be doing it at a larger scale. That's really where the problems are going to lie. Guessing this max index didn't work. How does it, let's see. 1 and 5, oh, it's 1 indexed. It's, yeah. So 5, if it gives 1 and 5, it means so these, well, yeah, we can think of these as both being 1 indexed, and then we'll go from in the range 0 to 4, but the range is not inclusive, right? Okay, so that was definitely not the solution. Min index. Oh, this needs to be a minus, actually. The min index and the max index, and then in order to make it inclusive, we would need to do max index plus 1. There we go. Okay, I'm going to submit it, but I'm going to go ahead and guess that timing-wise, this isn't going to fly. Yeah, see, so these longer ones, yeah, that's where the time's really going to start to hit it. So the logic's correct. It's just that the timing is not. Yeah. But these guys worked. These guys worked. So we do have 2 for loops, which looks scary. And that's for queries and for, I guess, whatever these are, potentially n. Yeah. And then the max value, that's going to be another, that's big O of n, where n is the index size, which I think is, yeah, correct. Well, we'll definitely have to go through all the queries. We definitely will. And if there's a way, I was going to say, if there's a way to only complete the operation on indices that have operations done on them, we should do that. But I'm already doing that because I'm only doing the index between the min and the max. So that's decent. Trying to think if there is a way to. There's a way to. Okay, well, so k equals 0. We should only do this if operation is greater than 0. I'm guessing that's not going to help much. We might get like one edge case or something like. I bet that too. I think that one didn't show up before. But yeah, see all these other ones, it's just taking so long because there's so many numbers. So logic's correct, but that's it. Edge case of max, yeah, we already have that one. I don't think there's a. There's gotta be a way to like filter out maxes and mins as we go, so we can just sort of like push them to the side. You could, I mean, you could definitely like break it up into. So have the arrays, but have one for each query, run the query operation on it, and then add them all back together. You could do that, like kind of distributed, and then bring it all together at the end. I don't know enough asynchronous Python to do that, and I don't know if there would even be enough of a gain to make it work, to trim down all the time. You could probably use NumPy or Pandas. I'm not as familiar with those. Did they say anything about kind of CPU powers behind it? I bet there's not too much. Just time and memory. Okay. 512. You have 10 seconds in Python. It's interesting that it changes the amount of time you have for different languages. Lisp, Lua, Erlang. JavaScript's 10 seconds too. How very interesting. Oracle, Microsoft SQL. If you could do all this stuff in Microsoft SQL, I'd be very impressed. I'm guessing that's not for standard questions. Surely not, right? Yeah. I guess what the real question is can you find the maximum value without calculating all of the values? If there was a number that had every operation done on it, that would be the max value. So I paused and unpaused the recording. That's why the timestamp skipped. One thing to do. So I know that I've been trying to figure out and think about ways that we could find the intersections of certain points, find out how it all kind of shapes out before we do these queries. But all that would really do is eliminate this part. And one thing that you could do instead of having this for loop in here is just have set limits and then figure out what the actual numbers are within the range in here. So instead of creating this max function, we'll have our own max function. So all of these queries, what we'd pretty much do is we would move left to right, and we need to know what happens as we're moving left to right. So if we're doing it in this queries loop, what we're doing is the range in the left to right. But another thing that we can do is instead of calculating all of this however many times, we can just add it for the beginning, subtract it for the last element, and then sum it in the max array. So instead of this, what we would do, so instead of using this range, we know for a fact that at this min index, we're going to have an addition of the operation, right? And then at the max index, at the max index, we don't have it. So everything after this max index, we won't add it up for it anymore. And then now we know this will tell us where in the indices our operations occur initially, and then as we're going through to find the max, we'll add those up and more or less do the range within the max value. So for element in array, we'll also have a max value. We'll initialize it out here. And then for element in array, we will have element plus equals max value, and we'll also need current value, or value might not be correct, current sum of operations is equal to 0. So we're going to start off with 0. So then current sum of operations is going to be plus equal to the element. And then if the current sum of operations at any time is greater than the max value becomes the current sum of operations, and then we'll return the max value at the end. So what the minus portion was doing in this queries is it was saying we're not going to add operation onto anything after the max array. So now let's add in a print statement for the array just to see what it looks like whenever it's done with these operations, and then before it calculates the max value. And let's run this. So it did work, so that's good. And this is what it actually looks like. So we would go 100, 200, 200, 200, 100. That's what the first one would look like. So 100 on 1, 200 on 2, 200 on 3 and 4, 100 on 5. So this next one, it's 10 long. So here, I'll write it in a comment what it will look like at the very end, and then we'll look at my debug output. So we have 1 through 5 is 3, 2, 3. Starting at 4, it's 10. 5 is 10. Then at 6, we have 7 plus 1 is 8. That's 6, 7, 8, 9, 0. So what we're looking for are the changes, the deltas, because we're kind of imagine like building a mountain. So we have plus 3, and then we kind of plateau. Oops. We plateau. So these will be zeros. Then we have a plus 7. We plateau here. Then we have a minus 2. For us, it'll be minus 2, but it will look more or less like minus 3 plus 1, because the 3 is done now. So we would have a minus 3. We would have put a minus 3 here before, and then we put a plus 1 starting at 6 here. So it's minus 2. Plateau. And then our 7 runs out, so we have a minus 7. Then our 1 runs out, we have a minus 1. So here we have the 3's, which go from here to here. Then minus 3 plus 1. Then the 7's, which go from here to here. And then the 1's run out. So that's what the debug output looks like. Whether or not this actually solves the time problem is another question. There you go. It solved the time problem. And I earned my 3rd star. Awesome. So there you go. That's how I decided to solve array manipulation. I got my 60 points. So thank you for watching. I'll see you in the next one.